It would seem as if the world would become a dead planet. But life is present on the Earth today, so where could it have taken refuge?
And an even more extensive, and we think very interesting, place where life would have survived would be in cracks that would always develop because the sea ice is flowing, whereas the ice that is at the coast would be frozen and locked in place. And therefore, there will always be a shear between the glaciers flowing in the ocean and the land-fast ice. And so cracks will continually open and then freeze, and then open and freeze, and open and freeze. And there's a very rich biota that lives in cracks and in channels of salty water that get enclosed within new sea ice.
How a snowball event gets started is still not fully understood. But strangely, it may have something to do with the gases which keep the Earth warm. Moderate levels of carbon dioxide help to keep the planet warm. But there is evidence which suggests that prior to the first snowball event, these levels were far lower. If so, what kept the planet warm? A large area of wetlands and swamp in the southeast of the United States can give some clues to the makeup of Earth's early atmosphere. The Okefenokee National Wildlife Refuge covers an area of 400,000 acres. The shallow, warm water is sometimes only knee-deep. Beneath the surface, the swamp floor is soft and spongy.
Now, right here is the Loblolly Bay. Is this tree in front of it?
Don Berryhill was a science teacher. Now, as a volunteer guide, he enjoys sharing both his love for the area as well as his love for science.
See where I'm digging down here? Look what's coming out. All right, that's a gas that's produced by the bacteria and the fungi down there.
As soon as the bottom of the swamp is disturbed, gas bubbles escape.
Now, that's the purpose of having it on the stick, so we can get it. No, not yet. We're losing our gas.
It is a highly flammable gas called methane.
There, you're good. You got it. All right.
This gas is sometimes used in households for cooking, but here it is produced by microbial life
There it is.
called methanogenes.
Sit down. That's a tutter.
Unlike so much life on the planet today, methanogenes don't rely on sunlight for energy. Instead, they get their energy by breaking down nutrients and making methane as a waste gas. Scientists believe that methane was the greenhouse gas which kept the early Earth warm. As methane bubbles to the surface, we now know that climate change is nothing new, and is a specialty for Dr. Jim Casting of Pennsylvania State University, who is a leading researcher in atmospherics. His research shows that if there was no carbon dioxide in the atmosphere, methane alone could keep the climate well above the freezing level.
But if you go back prior to the rise of oxygen around 2.3 billion years ago, then methane levels could have been much higher. There might have been 1,000 parts per million of methane, and that by itself would be enough to counteract the reduced luminosity.
He believes that the atmosphere then would have appeared reddish because of the high methane levels. At that time in the planet's existence, there was no life on land, no plants, no animals. The only life forms were microbial and lived in the oceans. Methanogenes belong to a group of microbes known as the Archaea, a different branch of the tree from which the microbes were eventually to evolve to higher life. They belong to the family Eukarya, and they are the ancestors of life today. Then a totally new organism emerged into the oceans. Perhaps a single cell mutated when reproducing. It's something we'll never know. But these cyanobacteria were to change the world. They were the first organisms to convert sunlight into energy and as a byproduct produce oxygen, a process known as photosynthesis. Oxygen was released into the atmosphere in huge quantities. And in those days, there was nothing that could use it. Dr. Casting thinks that it reached a level when its reaction to methane accelerated, eventually eliminating methane from the atmosphere. Over time, the world would change from its reddish color to blue. With nothing to stop it, oxygen production continued unabated for millions of years.
These little microorganisms, caused the rise of oxygen, caused the decline of methane, and triggered a global glaciation, which, may have come close to wiping them out.
Then the sun was smaller than it is today, so with the warm blanket of methane removed, the world began to cool. There were no other greenhouse gases to warm it, so slowly the planet began to freeze. Life had kept the planet warm, and now life was bringing chaos and disaster.
What we have learned is that when there is a mass extinction, in the aftermath, those organisms that are quick off the mark and can take advantage of empty ecospace and seize those places, even if they're not the most advanced or most suitable organisms, if they can get there first and establish their foothold, they can be very difficult to dislodge. And so after each mass extinction, there's a new biota which takes hold and becomes ascendant for a long period of time, perhaps until the next mass extinction.
Scientists believe that if there were snowball events then, they must have persisted for millions of years. During that time, the face of the planet would have seemed a frozen and desolate wasteland, as parts of Iceland are today. There was perhaps a chance that life could survive in water beyond the oceans, living from the heat and energy that comes from the Earth itself. Iceland is known for its volcanic and thermal activity. The land has only a thin crust above the heated mantle of the planet. It sits very close to awesome power and force. Hot springs are found across the island where the heat of the Earth forces its way out. Places like these could have been a safe haven for microorganisms which like the heat, the thermophiles. Dr. Viggo Martinsson and his team work for a company which hopes to use rare microbes for research.
Temperature field, so the steaming coming up from that deep down in the earth.
And it's places like this where thermophiles can live.